Hi, this is Elliot Fishman, and welcome to part 2 of the earlier detection of pancreatic cancer. Is AI the light at the end of the tunnel? And I do hope so. Now, we ended the last part, which was part 1 of 2 parts, talking about the importance of the pancreatic duct. Remember, the most common reason for patients to have a misdiagnosis of pancreatic cancer early is because people don't appreciate the dilated duct with abrupt cutoff. Often it's small, 4 or 5 millimeters, and people let it go by. But that may be the earliest and only sign of early pancreatic cancer. Now, one of our guys, our excellent people in our lab, is working on looking at the role of the main pancreatic duct in IPMN grading. And again, the thought is, can we use radiomics not just to look at the duct and say it's large, it's 6 millimeters, it's 8 millimeters, but to evaluate the importance of different pancreatic structures in grading IPMNs using radiomics and machine learning, including analyzing the main pancreatic duct. Can we look at a lesion and say the duct looks suspicious for developing a tumor, or the duct does not look aggressive? Again, one of the things we like to do is analyze how the duct can be helpful and how radiomics can analyze the duct. And there's some preliminary results. I don't want to go through them with you, but we're working hard because this can be a very, very important discovery. Now, we've also shown that in neuroendocrine tumors, that CT is very accurate, not only more accurate than radiologists in detecting the presence of tumors, but also better than pathologists. Remember, when pathologists try to grade 1 or grade 2 or 3, grade 2 or 3 typically are resected, grade 1 is followed. Their limitation is the fact that when you get a biopsy, the biopsy is a portion of the gland, and it can be difficult to say what exactly it is. Well, the good news is it looks like with radiomics, we're able to determine with a higher accuracy than pathology who is grade 1 and who is grade 2 or 3. So managing of these patients will significantly change. Now, in doing the work of analyzing the accuracy of AI versus radiologists, one of our people in our lab, Felipe, developed this really nice user interface, and building out as a way of testing more accurately and quickly when you have users, which is one of the challenges. How do you compare to users? Because everyone is so busy. You want people to accurately analyze the scans, but they don't have the time. We believe this will help them. Also, the thought is to use natural language reporting and query to find information about the cases, to find information from the charts. Remember, companies like Abridge attached to Epic and can pull out significant information. Can we pull out that information plus additional information that's very pancreas-centric and be able to be more specific in choosing what our process is? And again, thinking about this networking, an ensemble radiomics deep learning framework. Here it is for pancreatic neuroendocrine tumors, but you could see from going from arterial phase imaging to 3D bounding boxes to tumor probability or predicted segmentation maps to a consensus classifier, and then with a high degree of accuracy being able to determine who does or doesn't have a neuroendocrine tumor and what is the grade of that tumor. All of this work is cutting edge and very exciting. The computer vision applications of diagnosis and management of neuroendocrine tumors, you can see from this schemata, from classification to prognostication as to outcomes, to image enhancement, to screening and optimal detection, to tumor classification. This ability to truly analyze in a way we've not been able to till now. And again, this processing pipeline, Felipe, again, working very, very well on this idea about an automated pancreas segmentation map, the ability to ensure reproducibility and remove the segmentation burden. With removing the segmentation burden from the radiologist or trained technologist, we're not sacrificing, hopefully, any of the accuracy. We previously told you about the study we were involved with. There was a study, multiple centers around the world looking at complex cystic pancreatic lesions that went to surgery. And at the end of the day, despite the expert surgeons and clinicians, only 40% of the patients really needed surgery. There was work done using AI at that point that increased the accuracy to 60%. Well, 60% is better than 40%, but could we do better? And Bert Vogelstein suggested it would be a good data set to analyze. So with Microsoft, we looked at whether their newest technology, this EBM, electronic boosting machines, can do better. And here's the article. It's well worth reading. And what this article showed is that explainable boosting machines, EBM, which has been used for heart disease, breast cancer, and even credit card fraud, what it does is it looks at the data and tells you how it reaches a decision. But it tells you how it reaches a decision by basically looking and giving you the clarity. Remember, people always complain that with AI, it's a black box. This is a clear box. And so it shows you how it makes a decision, what factors it considers, what lab values, what information. And then for the patient, it just doesn't say binary, operate, don't operate. You can see in this case, it suggested 76% discharge, 9% monitor, and 15% surgery. So only 15% surgery, 85% either don't follow or simply follow the patient. The classic techniques, MOCA or the current management, would have taken the patient to surgery. So this was a good example of a patient who did not need surgery because of the information present. And when you look at the current state of the art, and now you look at EBM, which is going to be the new state of the art, we're able to do substantially better. And you can see all of these numbers. You can read them as well as I can. But the most important was you would have avoided 92 unnecessary surgeries, 59% reduction in surgery. And pancreatic surgery, as we know, has morbidity and mortality. It's Whipple's or it's distal pancreatectomies, all sorts of potential problems. Now, in this article, it was clear that 25% of the patients in the study would have had their management changed if we use this EBM. So we're very excited about that. And we're doing additional studies, including with the University of Pittsburgh Medical Center, with Anne-Marie Lennon, looking at new data from that institution and seeing how well these algorithms work. What's in progress? What else is happening? Well, this is some hot off the press work. This is with Felipe from Microsoft. His algorithms for being able to look and detect early pancreatic lesions, particularly smaller lesions, using coordinate attention blocks and global classification, using channel attention modules and spatial attention module, which I won't go into. But what we're able to do is have high sensitivity and specificity for detecting lesions. If you look at the Panorama study, which was nationwide, worldwide actually, and this was the best trial. But the thing about it was either with pancreatic cancer or not pancreatic cancer. In the not pancreatic cancer, there were normals, there were cysts, there were all sorts of things. So it's really a difficult study. So all you were looking for was pancreatic cancer, and you could see their AUC. Well, with us, we're able to have better specificity, higher sensitivity, and a higher AUC by using our technique. And again, what we can do with our technique is modify the specificity for higher or lower sensitivity, depending perhaps on the population you're looking at. But again, here we're much more accurate in separating the tumor types, as well as not simply saying pancreatic cancer or not pancreatic cancer. And you could see, for example, if you look at this case, this was a 2-centimeter lesion. You can see what the computer does, and what we're working on is not saying yes or no, pancreatic cancer or normal, but it gives classification probabilities not for a large population, but for the individual patient. So in this case, it was 0.98 for pancreatic cancer, but 0.74, it could have been a neuroendocrine tumor, but it's not going to be a normal case. It needs surgery. And its likely diagnosis, high sensitivity and specificity, was pancreatic adenocarcinoma, or in this case, with a markedly dilated pancreatic duct. Again, the PDAC 0.95, cyst, unlikely, neuroendocrine tumor, unlikely. So again, this prediction of a large pancreatic duct didn't see the tumor as well as one might like, but knew 100% this was a pancreatic cancer. This also goes back to the work we're doing on looking at the pancreatic duct, because that work becomes very critical looking forward. And when you look at our results against the best articles published in the world, our sensitivity and specificity for picking up pancreatic cancer was higher. We're working on a paper on this. We're going to publish it. There's a couple papers in press, a couple papers coming out. So indeed, it's very exciting. The last thing I'll mention is, I mentioned a little bit before about LLMs, and we think that LLMs can help transform unstructured radiology reports into structured templates, which will help us with analysis of data, particularly with things like IPMNs. So we are looking very carefully at how we can use large language models to help us. Again, we need all the help we can get. You want to get all the information you can from the medical record. Perhaps there are findings in the medical record that allow you to be more precise and more specific going forward. So the future of pancreatic imaging and staging is exciting. We need to improve scanning protocols, and we're working on that. We're working on improving cinematic rendering and trying to make it automatic. We're working on better AI algorithms. We're trying to optimize radiographics for tumor detection, as well as nodal involvement, as well as predicting who will do well with chemotherapy or with surgery. And the good news is AI progress is occurring throughout the world, whether it's the US or China. There are no trade barriers in the fight against pancreatic cancer. We need to find the best-in-breed products. They need to be tested more vigorously, and we look forward to implementation of AI for pancreatic cancer in clinical practice over the next several years. So with that, I thank you for your attention and have a great day. If you like this video, make sure to subscribe to the CTisus YouTube channel. You can also visit us at ctisus.com for even more videos, plus quizzes, pearls, protocols, and oh so much more. We're also in the App Store and have well over a dozen apps for iPhone and iPad, all completely free. Thanks for watching.